Okay, so this is page 57, word problems with multiple unknowns. Okay, so it says here, one of the keys is to solve the problem representing the multiple unknowns in terms of only one variable. So say you have two brothers, you don't know how old they are, but you will represent both of the brothers with the same variable. Like if you know they're 5 years apart, one is x, one is x plus 5. So we've done that before. Does that sound familiar? Yes. Okay. So like Johnny is 7 years younger than Charles. So Charles's age is C and Johnny's age is C minus 7. Why do you think they use C? They're using the C so you remember that that's Charles's age. You could just use X if you want. Doesn't really matter what letter it is. If you have consecutive integers, remember we did this before at the end of last year? You say the first number is n, the second number is n plus 2, and the next number would be n, second of even. So n plus 2, and n plus 4. Okay, so there's a little chart you have to remind you of how we did those. Also, for each of the next 2 months after May, the number of visitors to the national park tripled. So the visitors in May was V for visitors. Visitors in June was 3 times V, and the visitors in July was 9 times V. So those are just ways of representing the math, in terms. You had 3 different things in terms of the same letter. Eventually, we will have an X and a Y, and we'll learn how to solve problems with X and Y, and even X and Y and Z. If you have 3 equations with 3 variables, you have to do certain things to get answers for each one. That will be down the road. But right now, we're just naming one in terms of the other. And we're going to practice that before we get more complicated. All right, so page 58 says, solving word problems with multiple unknowns. First, read for understanding. Okay, so first you're going to read the problem and try to figure out what is in the problem. Now listen, life is busy, lots of distractions, lots of things on your mind. I have lots of things on my mind. Sometimes it's hard to clear your brain and just focus on the situation, okay? So if you read the problem the first time and you need to read it again, read it again. I read the problem several times because my brain is swimming with stuff, and I sometimes have to keep working on clearing it out, okay? It is how it is. So I think that's why sometimes boys do better in math, because they can clear their brain a little easier. You think so? You just go, okay, next job. Girls are always like doing 15 things at one time. Okay, that's what I've learned through the years. Okay, so doesn't mean girls can't do stuff. It just means we have to focus. All right, so read for understanding and represent the unknown. So you're just gonna, figure, okay, here's my letter. How am I? And if you have to do this more than once, that's okay. Like sometimes when we do it in class, we're kind of quick, and it's okay to take your time. Sometimes it's trial and error. I name it this way and it doesn't work out, so try something else. If you have to do it, I tell you this because sometimes we think it's, just automatic, you should be able to do it lickety split. But that's not always the case. We only have a few minutes. Sometimes I can remember times when I was a kid, because I can remember having a big class when I did algebra. I thought everybody else knew what they were doing, but I didn't. I go home, my mother could not help me. So I had to like read it, walk away sometimes, come back to it. Or sometimes you go, I'm going to go do something, go jump on my pogo stick, then come back, and all of a sudden I see it differently. Okay, so that's how these things are, especially word problems. Okay, if you work it out, it's not coming out, take a little break, get a drink, come back to it, and sometimes it works out. I'm telling you this because everything in math is not instant. Like when you learn your multiplication tables, that should be just like this. You know your multiplication tables like you know your name, because that makes everything else easier. But when it comes to something like a word problem or something you have to figure out, it could be a little bit more work and a little more, trial and error. So first of all, you're going to read it. Then you're going to represent in unknowns. Identify keywords. We talked about those, like if it says in addition to, if it says, more than, stuff like that. Choose a variable, represent it with a variable. Write and solve the equation. Look for statements of equality. Then you're going to solve the resulting equation, state and check the answer. Okay, I usually say also to, make sure that you answer the question. Like if it says, you solve for X and that's Charles's age, but you want to know Mike's age. Or if it says, what are both the boys' ages? Then you want to have both answers. And you also want to label your answer to make sure you answered the question. It says, how many books in the library? You say 15,000 books or whatever it is. Make sure you answer the question. State and check. So you state your answer, check your answer, and make sure and label your answer. Make sure you answered the question. I'm just going to put a question on it for a reminder. Okay, that's about it. I'm not going to go through all of these examples. We'll just kind of do some in our lesson. Okay, for the sake of time, we will do number 1, okay? We have the sum of two numbers is 85. If the first number is 4 times the second number, what are the numbers? Okay, so who wants to tell me what I need to do to get started? Anybody? Come on, everybody should be writing something down. Let's get started. The sum of two numbers. So what does that mean I'm going to be doing? Adding. Sum of two numbers. So adding. Plus n. Okay, the sum of two numbers is what? 4n plus n. 85. The first number is 4 times the second one. Okay, so I would just make a note of that. And then the first number is what? 4n. X. The second number is 4x. You could say x or n or whatever. So two numbers. So I'm going to read it again. The first number is 4 times the second number. Okay, so you said 4n for the first one and x for the second one, which is the same thing. Doesn't really matter as long as you have two numbers, right? So now what do I do? Some numbers added together. So the first number here, second number here. Combine them. Okay, now I'm going to combine them. And what do you get? 5n equals 85. 17. Okay, and so what was the question? Brody, can you get your paper out and start writing? What was the question? What are the numbers? What are the numbers? So one of the numbers is going to be 17. What's the other number? So I could either do 85 minus 17, or I could do 4 times 17. That should be the same number. Okay, so that number is right there. Okay, so everybody should have this written down in their book. This is part of your assignment. Page 60. This is number 1. Do you write it down? I want all of this, not just 17 and 68. Okay, so you could, if you want to do consecutive, you can leave a little space, and we're going to go to number 3. I'm going to just kind of see if I can get through the odds during class. Separate the number 39 into 2 addends so that the first is 5 more than the second. So if I have addends, what does that mean? Addends, what does that mean?
2 numbers you're adding.
Added together, just kind of like this one. Okay, if there are words in there that you don't know which operation that you are going to do, I think there was a little chart at the beginning, wasn't there? I'm pretty sure in this book there was a chart somewhere. Anybody remember what page that was? Can't remember what page that was, but okay. 12, there's some arithmetic operations, procedures. Page number 12, there's a little chart. You can make your own little chart, you know, when it says the sum, it's adding. It says, you know, there's lots of words. Oh, okay, here we go. Page 24. Keywords and algebraic meanings. Okay, so addition has some, subtraction, multiplication, division, and equality. So you could review that little chart for help. So you're going to separate 39 into 2 addends. One is 5 more than the other. So we have 2 addends. Together they are what?
39.
Okay, and then one is X, the other is, all right, so then I'm going to put them together. X plus 5. Now I did my equation. Now I'm going to combine. So 2x plus 5 equals 39. 2x equals 39 minus 5, which is 34. Divide by 2, x equals 17. No, is that right? Yeah. Okay, so one number is going to be 17. The other number is
22.
All right, now look at the question. Number 3, it says, what are the numbers? So 22 and 17 is correct. Okay, so that's what it should look like on your paper. So you're not going to have, Brody, you're not going to just put 1, 2, 3, 4, 5 with one line. You're going to have all this. This is number 3. So this is going to be probably 1, 2, 3, 4, 5, 6 lines. Each question is going to be a little bit of space. It's not going to be just an answer. Because I want to see the work and I want you to practice. Okay, it's like when you go to play soccer, the coach doesn't say, you know, here's the goal, you're just going to kick it in the goal. You know, it's easy when nobody's, you know, in an actual game. Okay, the idea is we have to practice so when we're in a game, we can actually get it into the goal. It's a lot different when you're in the game than it is, you know, you're the only one on the field and there's a goalie there and there's ball there and a free goal. You just kick it in. It's easy. I can remember my son, my oldest boy, I had the 3 girls first, and then my son Ricky. I could tell he was a lot different. And he turned, I think it was 12. I'm like, I think we should get a basketball hoop, you know? So My husband's like, yeah, that's a good idea. So we get a basketball hoop, we put it up. He never used it. He's like, what's the point? I know how to throw a ball into a hoop. I'm like, there's something you don't really know. Like, we need to get you around other kids. So yeah, he was just not that interested. It's a lot more fun when you get somebody to compete with. All right, so number 5. Number 5. The sum of 2 consecutive even integers is 46. So we have the sum again. 2 consecutive integers is 46. So you can, is it say consecutive or even? Oh, even. So the first one's going to be x, the next one's going to be what? X plus 2. The sum of 2 consecutive even integers. So the first one's going to be x, the next one's x plus 2. So now you're going to solve. So x plus x to x 2 equals 40. So you're going to subtract side by 2. And so the question is, what are the numbers? So the first one's going to be 22. The next one's going to what did I say? In my mind, I saw the negative 27 and I said, my brain's doing flip-flops on me. Okay, so n, and you got n plus what? It says 3 consecutive negatives. So it means the next number is n plus 1. The next number is n plus 2. And altogether, they're going to be negative 27. Okay, so hopefully my students come back. Yep, they're there. Okay, so now what do I do? Yeah, you got this all done, Henry? Why are you not participating? Keeps going in and out. Negative 30. Divide by 3.
You're gonna get n equals negative 10.
All right, so if n is equal to negative 10, I'm going to try plugging this in. It could be that. No. Okay, so the first one is negative 10. What's the next one? N plus 1.
Negative 11. And then negative
No, plus 1.
negative
Plus 1, and then
I
plus
know.
1 again. All right, so now see if that adds up. Negative 17, negative 27. If I did negative 11, then the 3, if you get 3 numbers, you have to test it to make sure it works. Okay, so That is correct. So number 9. In a class of 35 students, there are 5 more boys than girls. How many boys are in the class? People say, I never use math. Tell me when I've used math before. And then they say, I hate doing word problems. You know, sorry, but you use math a lot more than you. I was talking to one of the classes, like probably 7th grade. I'm like, don't get so stressed out. You use math all the time. You went to the store, you saw a coat. Okay, you saw a coat you wanted for $20, but you have 15. Can you buy the coat? No. You'd be calling your mother, say, hey, can I have $5? Or you have your friend there, can I borrow $5? But this is the thing about nowadays, you can put it on your card. So if you put it on your card, you don't really have to pay for it. Well, how it goes?
Go into debt. Just buy everything.
If it goes on your card, how do you pay for it?
You have to pay the bill. You have to pay the bill because of the money you spent.
Okay. So you know the difference between a credit card and a debit card,
Yeah,
right?
debit card.
Right. So like maybe your parents let you have a debit card because you know you only have like, $200 or something. But a debit card, you can put, stuff on it, but eventually you do have to pay for it. But I literally went to a Dunkin' Donuts one day and I used a card and I asked the kid behind the cash register, I said, how much did I pay for that? Because I paid for someone else and I just wanted to know how much it was altogether. And he looked straight at me and said, you didn't have to pay for it. You used your card. And I was like, so it's kind of a joke with my kids now because I actually never had a card when I was a younger mom. We always did cash because I'd be like, just give me cash for the week. And when the cash runs out, I have no more money. I didn't use a card. And now I do use a card, but I do keep track of it. Like you can keep track of it online, all that stuff. But I always tell my kids, so it's weird for them, especially my older kids, to see me use a card. So then I'll just joke around and be like, hey, I don't have to pay for it. I can just use my card. And they're like, yeah, I know. So anyway, it's kind of fun. But that's the danger of the card is you can't see it. So then you can rack up the bill. Like even sometimes I'll go get gas. I go get, some groceries. I go get, whatever. And then, the money runs up and then you look and you go, wow, I spent $200 and I hardly even noticed it. That's what they want to happen. They want all of us to be in debt. But if you're smart about it, you don't have to. You can use the card for your advantage. You don't have to go into debt. You just have to be careful. That's why you do math class, because you want to be able to add numbers and be responsible. Okay, so we have 35 students. What are we going to do here? $35 students. What's next?
So x then plus x plus 5.
All right, so one is x plus 5, and then what do we do?
2x plus 5, and then 35. So you subtract 5 from both sides. And it's 2x equals 30. And you divide by 2.
All right, so the question is, how many boys are in the class? So is this boys or girls?
That's girls. And then
there are 5 more boys, so this would be girls.
And then there's 20 boys.
All right, and that's the answer. Okay, so moving on. A carpenter wants to cut a 45-inch board into 2 pieces, such that the longer piece will be 7 inches longer than the shorter. So you could just draw a picture. So one is x, one is x plus 7, and altogether it is what? 45 inches. And the question is, how long should each piece be? What am I gonna do? Mila? What am I gonna do next? So I just said, like, you could draw a picture if you want, kind of, that helps too. If you're doing something with construction or shapes or distances, draw yourself a picture. Okay, I don't know why you just closed your book. You don't want to write this down? Still got 7 minutes to class. Okay, so I'm gonna set up my equation. And I'm gonna get x plus x is 2x. And then subtract 7. And then divide by 2. Okay, so the question was, how long should each piece be? So one piece is going to be 19 inches. The other one's going to be 19 plus 7, which is
26.
26 inches.
You're 10.
Add them together, what?
You're 10.
I couldn't, you talk so fast sometimes I can't always understand. Okay, the sum of 4 consecutive multiples of 3 is 138. Okay, so what would that look like? Did you set anything up?
No, it's why I'm asking.
Okay, so if I said the first number is x, what would be the next number if it's a multiple of 3?
X times 3.
Okay, so x, 3x, okay, and then what else does it say? Sum of 4 consecutive multiples of 3 is 138. Okay, so in this case, instead of multiplying, we're going to say, like, say I'm doing multiples of 3. It's 3, 6, 9, 12, 15. What did I do to 3 to get 6? I just keep adding, right? In your mind, you're adding 3, adding 3, adding 3. So the next consecutive would be not 3x, but x plus 3. And then it says the 4 consecutive. Well, I start out with this, the next number is going to be x plus 3. That would be the second consecutive. Third consecutive would be x plus 3, which is 6. And the fourth consecutive would be x plus whatever this is, and then add 3. Okay, and then it says the sum, so that means you're adding them together, and then together they equal what? 138. So that's going to be your problem right here. Okay, so now you're just going to add. You could make parentheses like this if you want. It doesn't really change anything. But now I add 1, 2, 3, 4 x's. I add 6 and 9 is 15 plus 3 is 18. Subtract 18. Divide by 4. All right, so the question is, what are the 4 numbers?
30, 32.
Right, so I'm going to start with 30 and then just keep adding 3s. And now if you want to check it, if they add up to 138, you add them up. So 15, 16, 17, 18, 3, 6, 9, 12, 3, 6, 9, 12. Plus 1 is 13. So adding them together, I do get 138. Okay. We did 11. Number 13, Jamie is 3 years younger than her brother Charlie. The sum of their ages is 27. How old is Jamie? So instead of adding 3, we subtract. So the first age is X. The second age is X minus 3. And their sum, if we add them together, is equal to 27. So we do it the same way. You just have to remember to add 3 to each side, which is 30. So the first person is 15. The question is, how old is Jamie? Jamie is 3. So this number right here is the older kid's age, 15. So Jamie is going to be 15 minus 3. So Jamie is 15 minus 3, which is 12. Okay, so you just got to make sure you answer the question. Okay, then we have Joey's age is 4 more than 1/3 the age of his grandmother. If the sum of their ages is 100, how old is Joey? So Joey's age is 4 more than 1/3 the age of his grandmother. His grandmother is G. The sum of their ages is 100. Okay, so that would be your problem. 4 plus 1/3 G plus G equals 100. So then you're going to subtract 4 from each side. How do I add 1 plus 1/3? So you just go 1/3 plus 3/3 equals 4/3. So I can make that 4/3 G. Okay, now what can I multiply by G to get 1? Remember that one?
3/4.
The reciprocal, correct. 3/4, so I do that on both sides. Okay, so over here it cancels to 1. Over here, you divide by 4 and then multiply by 3. So 24 times 3 equals 72. And then test it. See if you got the right answer. All right. Enjoy this assignment. See you tomorrow. Page 16 under 24.